All right, guys. So we were at 3A.2 part B. All right. So quickly on part B, we made it as far as talking about central angle. The central angle is the angle created from the origin to the intercepted arc in between, right? That's our central angle. Um, we also talked about how for our central angle, this is the arc, the R, it's a part of the circumference, right? All that good stuff. And what else did we need to talk about? I think that was it. Then we went into converting, correct? So converting between degrees and radians and making sure that we understood that when we're going from degrees to radians, it's theta times pi over 180. Radians to degrees is theta times 180 over pi. And we want to simplify and reduce. Fractions are our friends. Friends. All right, so we're on the back side of 3A.2b. Yes? Are we here? Yeah, we're here. All right. So here we have a radian, and we want to talk about rotations of radians and how they're moving around. If I have negative pi over 4, what we're going to think about here is you're literally dividing pi into parts. Pi is half of a unit circle. So when you have half of pi, you're thinking about if I divided this into 4 pieces, what does that look like? So I'm going to take my highlighter and I'm going to show you what that means. So we talked about that going around a whole circle is 2 pi, right? 2 pi radians is around a whole circle. If I just have pi, this is 1 pi, this is 2 pi. Agree? So if I am going around the circle, all I'm doing is dividing this quote unquote pi into parts, right? Into fractional parts. So if I'm looking for pi over 4, that means I am taking just the first half and dividing it into fourths. So this would be half a pi, right? So then each one is half of a pi. Yeah. This right here, is that what you mean? I don't know what you mean. So this is pi over 4. Then this would be 3 pi over 4. Does that make sense? Each one of these is a quarter of a pi. Do we see it? Is it not clicking? Yes. Because I'm counting by pi. I'm counting how many quarters of a pi that I create. So this is 1/4 of a pi. This is 2/4 of a pi, which is half a pi. This is 3/4 of a pi. This is a full pi.
So it's like it's not. It's just representing. It's like a clock.
Yes, but in terms of pi. Okay, so this is where this would normally be. Does that make sense?
Yes.
Because we rotate counterclockwise. Yes? Agree?
Yes.
All right. Now, this is negative pi over 4. Negative pi over 4 means that instead of me going counterclockwise, I'm going to go clockwise. So I'm taking the bottom half and I'm dividing that into parts. Does that make sense? So if I'm looking for negative pi, I'm going to come down here and I'm saying, okay, here's my bottom half of 2 pi. So this is still pi. This is now cutting it into quarters. So this is negative pi over 2, which makes this negative pi over 4, which makes this negative 3 pi over 4. And when I end up here, this is going to be negative pi because I'm going rotating this way. And the reason why I'm rotating clockwise is because it says to sketch negative pi over 4. So negative pi over 4 would be here. So when I sketch it, this is its initial side, and this is its terminal side. So this angle right here is negative pi over 4. Yes, your initial side is always the positive x-axis. So this is our theta, which equals negative pi over 4. Okay? So like if you literally think of 2 pi as a giant pie, and you're slicing it into parts to figure out the pieces Okay, so we've already talked about it here. On this one, can I easily identify where pi over 2 would be? Yes, and it's at my y. It's at the top of the y-axis, right? This is pi over 2. So therefore, my initial side is here, and this is my terminal side. So this angle represents theta, which equals pi over 2. Okay, then on this side, it's asking me to divide into thirds. Okay, well, dividing into thirds is a little different. It's a little harder, right? I got to divide into thirds. So I need to have 2 pi thirds. So I'm taking pi. So when you read this, I know it says 2 pi, but it's 2/3 of pi. Does that make sense? So I'm taking pi and I'm dividing it into thirds. Yes? So my thirds would look like this. Do 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 do. Do you see that I have 3 equal pieces, or my attempt to draw 3 equal pieces? No, because I'm creating thirds. I'm creating thirds, so they're not going to be equally down the floor. Does that make sense? So here is one slice of my third. Here's another slice of my third, and here's my final slice of my third. Do you see it? Okay. Now, is your teacher the most accurate drawer? No, but she tries really hard. Okay. So I'm looking for 2/3. So here's my initial side. And this is going to be 1/3. Does that make sense? Then this has to be 2/3. So my terminal side is going to stop here. Huh? Why is the top 2/3? Because I wanted you to understand that 2 pi thirds means 2/3 of pi.
Oh,
No, this is saying that this means 2/3 of pi. Okay, so therefore my terminal side would be at 2 pi over 3. And this would be my angle. So this is my theta, which equals 2 pi thirds. So do we see that all you're doing with the unit circle is based off the fraction that you're given, you're creating parts? Yes? If it's negative, then I'm creating the parts I'm rotating clockwise. So it's going to create the parts going the opposite direction. All right. Yes. Okay. Yes. All right. So next, we're going to talk about analyzing radians in other forms. So the minute hand of a clock travels how many radians in 5 minutes? Okay. So if we're looking for how far it travels in 5 minutes, what we are analyzing is its relationship to the circle to a clock. I don't have a regular clock in here for us to look at, but yeah, but it's already has the measurements, the trig values on it. So let's talk about this. But we understand how a minute hand works, right? A minute hand travels around. How long does it take the minute hand to travel? 60 minutes equals an hour. 60 minutes is one full rotation. Does that make sense? So it rotates one rotation every 60 minutes. Yes? Agreed? So it wants to know how much is a travel for 5 minutes. So if I'm traveling for 5 minutes, so 5 out of 60, right? So if I've gone 5 minutes out of 60 minutes, it wants to know how far around the unit circle have I traveled. Does that make sense? So equivalency to how far around unit circle have I traveled. So, so this would equal x out of 2 pi. Does that make sense? Circle, full array around a circle is what? That's a circle, 2 pi. One full rotation around the circle is 2 pi. What is the head tilt for? Yes? Did we not come to that conclusion yesterday? Going around the circle is 2 pi? Huh? No, we said that when we wrote here. 2 pi radians is 360 degrees yesterday, 2 days ago. Don't try to make, don't try to be thinking I'm crazy, but I'm not. Okay? I knew what I said. All right. So if 5 minutes over 60, right? So therefore, how far around a circle? We're creating a proportion, right? All it's saying is create a proportion. What would that be in terms of going around the circle? Does that make sense? So when you're solving a proportion, all you're doing is what? Cross multiplying and dividing. Can we do that? Okay. So we cross multiply. We have 5 times 2 is equals cross multiply 60x. What do I need to do to get 60 by itself? X by itself. Divide by 60. And what do we get? We get pi over 6. So the equivalency would be pi over 6. So I took that circular motion. Once I figure out what one full revolution is, one rotation, compared to what I'm talking about, I then can compare that to the unit circle. Yes.
Well, it doesn't matter if you got 60x over 10 pi.
Yes. That's not the same. How did you get 60x over 10 pi?
Because you bring 5, if you cross multiply 5, you get 1 and you get 2 pi.
If you had 60. Oh, you're talking about if you set up your proportion? No, as long as your values are corresponding.
So it could be 60x over.
Yeah, so for me, I did my full rotation out of the part. So it's part out of full. So this has to also be part out of full. If you did 5 minutes, I don't know how you would have set it up, but however you, as long as
5, 5. That makes sense.
I did, I cross multiplied.
But then you put the 10 pi on top.
Because when you have a proportion and you're solving, you're cross multiplying. It's eliminating the fraction. Like solving proportions, cross multiply, divide.
Yeah, but
5th grade.
cross multiplying.
No, I'm saying what did you do in 5th grade? Did y'all kept it as a fraction? Oh, no, it doesn't it eliminates the fact that it's a fraction. So when you're solving proportion and you use cross multiplication, it just now makes everything horizontal. It doesn't bring anything down. Huh?
Oh, never mind.
No, I just want no proportions are going to be a big deal. Okay, so it says what measure is radians is 45 degrees. So we're looking for the measure of time in a time. I said time tonight. Theta. That is 40x equals 45 degrees. So when we're looking for x equals 45 degrees, and we're just converting, right? Why'd you say negative? Yes, but you got to follow the red. So the red is doing what?
Oh, so
that's your arrow. So this is, there we go. This is the 45, right? And as Hudson said, this is pi over 4, but it's negative. So to figure out this value, we're subtracting from 2 pi. Does that make sense? The whole thing, the whole circle is 2 pi. So to figure out this value, we're subtracting from 2 pi, okay? Because the red is your angle, not this space. You're following the angle rotation. That's your angle of rotation. So to find this value, it's going to be theta equals 2 pi minus pi over 4. And the reason why we're subtracting pi over 4 is because that's the equivalent form of 45. Agree? And there you go. So again, in this situation, you can do cross multiplication. So if I was to do cross multiplication here, or you can find a common denominator. Really doesn't matter which way you do it. as long as you do it. Cross multiply. 2 pi times 4, 8 pi minus 1 times pi times your denominator. And that gives you, it's not an equal sign. And you end up with 7 pi over 4. Okay? What I like to call this is chopsticks in a bowl. Okay? Chopstick. Does it not look like chopsticks in a bowl? It does. It looks like chopsticks in a bowl. And we're going to just go with it. 11th grade me said this was chopsticks in a bowl. And we're going to hold true to what 11th grade me has been saying. I've been saying it longer. So call it whatever you want to call it. Okay? You do you. Like, I've been calling for 2 decades chopsticks in a bowl, and it's chopsticks in a bowl. Yeah. All right. So really quick. This is if you are not strong at finding least common denominators and you don't, or you just don't want to worry about it and you rather simplify the end. This is a quick way to add and subtract fractions with unlike denominators. Yes.
6x minus minus 9. Right?
6x minus 9.
To get the wait, oh no.
We're not there.
I like it.
So chopsticks works like this. Order does matter when you are doing chopsticks in a bowl. Okay. So you cross multiply from top to left to bottom. So you have 2 pi times 4 gives you 8 pi. Your rice is whatever the operation is. So my rice is minus. So 8 pi minus. Then you multiply from bottom to top. 1 times pi is pi. Okay. Then your bowl is multiplying both denominators together. So my bowl is 1 times 4, which makes it 4. This works for any fraction with unlike denominators and you don't feel like finding an LCD. Okay? So we end up with 8 pi minus 1 pi, which is 7 pi over 4. I can't reduce anymore, so that is what my angle measurement is. It's 7 pi over 4. How do you feel about it? Now, could you just simply have multiplied numerator and denominator both by 4 and still got the same thing? Yes, because 4 is an easy one to manipulate here. But again, it's just a shortcut. You don't have to use it. You can do however you want. But remember, when you're adding and subtracting fractions, they must have a common denominator. 101. Yes? All right. So next on C, what is the measure of theta in radians? So this right here, does anyone remember what this is called in geometry?
Obtuse.
It's no.
A cube.
No.
Can you tell us what it starts with?
It's the thing where it's 180, so it has to add up to 180. Supplementary.
There we go. There's supplementary angles. We were getting there. I knew someone had to remember. All right. They have to equal up to 180 because this is called, it's on a straight angle. And straight angles equal 180 degrees. Agreed? Straight angles, yes. What? No, it's not 3 pi over 4. Okay, a straight angle equals 180 degrees. So when we're looking at this, we have 180 equals x plus 5x. I'm starting off with 180 just so that we can relate it to geometry and then we'll convert it to radians. Does that make sense? Is that okay with you? All right, so we have 180 equals x plus 5x. So therefore, what do I do to solve? We get 180 equals 6x, and then we're going to divide 180 by 6. So we know x equals what? 30. So we know that x equals 30, and it wants it in radian form. So we would have to figure out what is 30 degrees in radians. Well, what is 30 degrees in radians? We just wrote it down. Just go back to, just do it the easiest way, which is just flip your paper over. How do you change from degrees to radians? Theta times theta times pi over 180. So we end up with 30 times pi over 180. What does that reduce to? Pi over 6. So 30 is pi over 6. So this little piece right here is our pi over 6. If this is 1 pi over 6, without having to do math, if together these have to equal a whole pi, what would make this one? I have 1 out of 6 here. There we go. This would be 5 pi over 6. Because together, they have to equal a whole pi, a whole 180. Does that make sense?
Wait,
Half of a circle is
the
pi.
whole thing has to be
The whole thing has to equal pi. All right, that is the end of B.